Hi, in this video, I will be showing you problem number 7 of chapter 10, section 1. Sketch the curve by using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases. B. Eliminate the parameter to find the Cartesian equation of the curve. X equal to t square minus 3, y equal to t plus 2. T lies between negative 3 and positive 3. So we will create a table to plot points. T is given to lie between negative 3 and 3. T is the parameter. And x and y depend on t by the relation x equal to t square minus 3 and y equal to t plus 2. So in the table, we'll start off with the value t equal to negative 3 and end with the t equal to 3. So in between, we can choose values between negative 3 and 3. So for negative 3, substitute t equal to negative 3 into x and find out the value of x, which is 6. Then if you plug in t equal to negative 3 into the relation for y equal to t plus 2, you get y equal to negative 1. So like that, you give values successively starting from negative 3 and ending at 3. For negative 1, you get x equal to negative 2, y equal to 1. For t equal to 1, x equal to negative 2, y equal to 3. And for t equal to 3, x equal to 6 and y equal to 5. Here in this graph, with the x-axis and the y-axis, we have plotted the points x, y, 6, negative 1, negative 2, 1, negative 2, 3, and 6, 5 are shown. So besides, like the Cartesian coordinates, we will stop here and then connect these by means of a curve. But here we also take into account of the value of t. So t equal to negative 3 corresponds to the point 6, negative 1. T equal to negative 1 corresponds to the point negative 2, 1. T equal to 1 corresponds to the point negative 2, 3. And t equal to 3 corresponds to the point 6, 5. Now we are going to connect them by a smooth curve and also give the orientation of the curve by an arrow. So the arrow is the main difference between a regular Cartesian graph versus a parametric graph. In the parametric graph, we also we see when the particle is at a specific point. So it not only gives the position, it also tells when the position was attained by the particle. That is a significant difference between a parametric curve and a Cartesian curve. So it's important to show the arrow how the orientation of the particle is by showing an arrow in the graph. For the second part of the problem, we are asked to eliminate the parameter to find the Cartesian equation of the curve. So y is equal to t plus 2 in parametric form. So if you solve for t, it becomes y minus 2. Then we have to substitute that for into t for the equation x equal to t square minus 3. So if you replace this t by y minus 2, then you get y minus 2 the whole squared minus 3. So this would give us y square minus 4y plus 4 minus 3, which is y square minus 4y plus 1. So which is a horizontal parabola, x equal to y square minus 4y plus 1. And we have to give the bounds for y, that becomes the input. Y is the independent variable, x is the dependent variable. So we have to give the values for y. We know that t runs from negative 3 to positive 3. So when t equal to negative 3, y equal to t plus 2, which is negative 3 plus 2, which is negative 1. When t equal to positive 3, the higher value, y equal to t plus 2, which is 3 plus 2, which is equal to 5. So y runs from negative 1 through 5. So x equal to y square minus 4y plus 1 is the horizontal parabola where y runs from negative 1 through 5. That is exactly what we see in the graph too. Y equal to negative 1 and y equal to 5 over here. So So it's important to write the domain of the function. Hope this video helps.